Okay, so let's take a look here at example 3. I always encourage you to try factoring by grouping the first two and grouping the last two and seeing if something works out there. If it doesn't, then worry about rearranging the order. So here we go. We'll see that if we group the first two and the last two, the first two we can factor out an a squared, which leaves us with an a plus 3 plus, now that last group is just a plus 3, which is what we have there. Now I'll put it in a group, okay, that's what we've got. That plus is what's separating the first and last terms. This is where I normally see students mess up in a problem like this, because what they'll do is they'll say, oh, I see, I can factor out that a plus 3, so they'll factor that out. They'll have their a plus 3 factored out, and then they'll say a squared is what's left when I pull that out. And then they say, when I pull a plus 3 out, I'm left with nothing, and then they just close it up there. That's wrong. If you factor, think about it folks, if you factored x squared plus x, okay, you can pull an x out, you're left with an x plus 1. You're not left with just an x, because you need that second term. So you have to think, what do I multiply a plus 3 by to get a plus 3? And the answer is 1. So this now is the factored version of it. I also see students that are like, I don't like that. That seems suspicious. I don't want to do it that way. I'm going to reorder it. And you can. Sometimes I'll see students do this. They'll say, hey, this is a 3, this is a 3. I'm going to put those first. 3a squared plus 3. That has an a and that has an a. So I'm going to write plus a cubed plus a. And then what they'll do is they'll group and they'll factor out a 3. And they'll be left with an a squared plus 1. And then they'll factor out an a. So they'll say plus a. And then they'll have an a squared plus 1. And they like this way better. That's perfectly fine. Then they group and see that that plus is making the two terms. And they'll factor out the a squared plus 1. And there's your a squared plus 1. And then you're left with a 3 plus a. There's your 3 plus a. You get the same result. So if you feel comfortable leaving that a plus 3 be an a plus 3, and when you factor it out, you're left with a 1, go ahead and do it that way. If you want to reorder it because you like that, the way this one looks, it's a little more work, but if it makes you get the problem right, I'd rather you do that with a little more work. Let's take a look at this second example now. So we've got this this 4-term polynomial. We'll try grouping and grouping. There's nothing we can pull out there. We can pull out a y, which leaves us with an x plus 2, but we don't end up with an x plus 2. So you have to figure out how to group it. Maybe you see this term has a 2, this term has a 2, and you want to group those two together because you know you can factor out the 2. So we'll use this approach. So plus, now look here. The first term, when we factor out the 2, is just going to be an x. Well, with these two terms that are left, this is the only one that has an x. So this makes sense to write the yx term first, and then the plus y squared term next after that. So let's see what happens now with this new order. We'll factor out the 2, we'll be left with an x plus y. Here we can factor out a y, so we have plus y, and then we're left with an x plus y. When you factor a y out, x. When you factor a y out, y. Hey, look, that plus now groups two terms that both have that x plus y as a common factor. We're going to pull that x plus y out, and that's going to leave us with a 2 plus y. That is the factored state of this. If you want to verify, it's not hard. First times first, 2x, boom. Outers make a plus xy, boom. Inners make a plus 2y, boom. Last times last makes a y squared, boom. you can see that it is correct.